In section 5.5.45, suppose 147 cars start at a car race. And how many ways can the top 5 cars finish the race? Since the 147 cars are distinct, no one car can be chosen more than once for the top 5. And the order in which cars are chosen matters. So since order matters, we're going to count permutations to solve this problem, since that's the definition for permutation, where order is important. So we're going to use the formula for permutations, which is n factorial divided by n minus r factorial. Now the value of n is the number of cars to choose from, so n is equal to 147. The value of r is the number of cars to choose, so r is equal to 5. So now we're going to substitute the numbers into the formula for permutations and simplify. So we know that we have 147 factorial in the numerator. 147 minus 145 gives you 142 factorial. So now, since we know that we have in the denominator 142 factorial, we can end in the numerator at 142 factorial. So we have 147 times 146 times 145 times 144 times 143 times 142 factorial. And since we can simplify those, we just multiply the remaining. And so therefore, we've calculated that there are 64,082,098,080 different top 5 finishes possible for this race of 147 cars. Now, if we want to calculate this on the calculator, then since we know the value of n represents 147, so we'll go ahead and enter 147. And then we're going to look for the permutation in the probability section under math. So we're going to select math, scroll to the right where it says probability. And since we're going to look for permutation, we're going to go down to number 2, select enter, and then put in number 5, since that's what r is equal to. And when we hit enter, then we're going to get this in scientific notation. And again, that means it's times to the 10 power, which means if we move that decimal over 10 times, then we should get the same number that we got for our solution.